Hello everyone, welcome to the lecture Deep Learning with Big Data. My name is Hamidur Rahman and I am a PhD student in Melardolan University. This lecture is divided into 5 parts, which are Part 1, Introduction to Deep Learning, Part 2, Basic Concept of Deep Learning and Neural Network, Part 3, Deep Learning versus Machine Learning Comparison, Part 4, CNN or Convolutional Neural Network, and Part 5, CNN Examples. So this is the first part of this lecture series, Introduction to Deep Learning. In this part, I will present the following topics. First, I will describe what deep learning is. Then I want to show you some deep learning applications. After that, I want to discuss why deep learning is so popular. I will also give a brief description about theories behind deep learning. And finally, I will show some popular resources of deep learning. So deep learning is getting lots of attention lately and for good reasons. It's making a big impact in areas such as computer vision and natural language processing. In this lecture, we will help you understand why it's becoming so popular. So let's see what is deep learning. Deep learning is a machine learning technique that learns features and tasks directly from data. Data can be images, text, or sound. In this lecture, I will use images, but this concept can be used for other types of data also. Machine learning teaches computers to do what comes naturally to humans, learns from experience. Most machine learning workflows use training images that represent examples of what the system is trying to learn. Computers learn from these images through feature extraction. This is where information like edges, texture, and color is extracted to form a reduced representation that easily describes the object. These features are then used by a machine learning classifier to learn a task. Deep learning can be applied to a variety of problems, including image classification, speech recognition, natural language processing, etc. So deep learning is often referred to as end-to-end learning. Let's look at an example. Say I have a set of images and I want to recognize which category of objects each image belongs to, that is cars, tracks, or boats. I start with a labeled set of images or training data. The labels correspond to the desired output of the task. The deep learning algorithm needs these labels as they tell the algorithm about the specific features and object in images. The deep learning algorithm then learns how to classify input images into the desired categories. We use the term end-to-end learning because the task is learned directly from the data. Let us look at another example where a human is playing table tennis with a robot. In this case, the task being learned is how to identify a ball, where is the location of the ball, and how to hit it. Using this algorithm, the robot can play a table tennis with a human and the performance is also very good. Many of these techniques used in deep learning today have been around for decades. For example, deep learning has been used to recognize handwritten postal codes in the mail service since 1990s, and the efficiency of the workflow is very good. Deep learning is also good for scene analysis. For example, let's have a look at this image. In the first image, dog plays catch with white ball near wooden fence. In the second image, man playing accordion among in public area. And in the third image, woman in white dress is standing with tennis racket, two people in green behind her. So deep learning algorithms for scene analysis is pretty good. The use of deep learning has surged over the last 5 years. This is primarily due to 3 factors. Deep learning methods are now more accurate than people are at classifying images. You can see here from 2010 to 2016 how deep learning performs better than computer vision or even human in some cases. GPUs enable us to now train deep network in less time. After using deep learning algorithms, the processing time is less than before, and large amounts of level data required for deep learning has become accessible over the last few years. Especially for big data, deep learning is wonderful. Therefore, still today, the performance of deep learning is better than any other learning algorithms. So, most deep learning methods use neural network architectures. This is why you often hear deep learning models referred to as deep neural networks. One of the most popular types of deep neural network is known as a convolutional neural network or CNN. It is especially well suited for working with image data. Deep learning nowadays more and more advanced to solve the real-life problems, including image classification to self-driving car. In last few years, deep learning is able to recognize speech also. A few long-standing performance records have been broken with deep learning methods. Many companies such as Microsoft and Google are using deep learning for speech recognition. Many computer vision problems are solved with deep learning algorithms. Also, deep learning algorithm has enriched natural language processing field. Let's have a look behind the theories of deep learning. Deep learning theories are divided into three categories, that is supervised learning, unsupervised learning, and reinforcement learning. In the supervised learning, the most popular algorithms are convolutional neural network and sequence modeling, that is recurrent neural network and its extension. Among the unsupervised learning, the pioneer algorithms are autoencoder, deep autoencoders, denoising autoencoders, and stacked denoising autoencoders. Reinforcement learning is another type of deep learning theory where deep reinforcement learning is also used. So here are some of the deep learning resources. Most probably you have heard some of the names. So have a look a little bit. PyLearn 2. This is a machine learning library built on Theano and written in Python. And Theano is a deep learning library. This is also written in Python. Caffe, a deep learning framework by Berkeley, written in C++. TensorFlow, a deep learning based Python library written in Python. And rest of the resources you can explore. So here is end of the lecture. Thank you very much.